Guess what? I'm back. Of course, the same thing. Want to think something else? Alright. Basically, I was up until this step. We got the DVA. And now we just have to solve this, which is quite tricky. Well, first of all, we need to get the same base, right? So 3 on the right, the 9 on the left. On the LOG base, I can write it down as 3 of power of 2. Yeah, that is correct. And then that 2 goes up front, I guess, with a 2x power of 2, stuff like that. I'm not really sure. So yeah, we really have to think about it. So this is like a top difficulty in terms of SAT. I mean, of course, it's not the SAT, but it's type SAT. So this is quadratic right there. When you solve a quadratic, how's that gonna help us? Well, this quadratic, I think it's x minus 3 and x plus 3, parentheses like that, which is like almost the same as 3 minus x. I don't know if that helps with something. So that is actually x minus 3 at the second power. Okay, so that is that. But who cares if it's like that? That has been moved to the left. Okay. It is x minus 3. It's not 3 minus x. What are you trying to do? Yes, 3 of the second power. That has been discussed. Negative sign and you flip it. I thought of that. But how is that gonna help? Exactly the same. We write it down. And the 2 right there, I think it couples with power of 2 right there. And they go up front, so it's pretty much nothing. 2 divided by 2 up front, so it's nothing. As far as I know. Okay, so we work only with that 2 for now, I think. So it goes like that. Divided by 2 up front. And right there's minus 3 plus x. Is that gonna help? 3 minus... So minus just disappeared. You are telling me that the minus has just completely disappeared. So, I think to solve this, first I need to understand where the minus go. Did the minus go? So I know where the 2 went. It went under the x to the second power. But where did the minus go right there? What kind of property has been used to get such a result? Well, yeah, I'm gonna research it. Be right back. Okay, now I understood exactly why this has happened. It's quite intricate. The minus disappeared because it's to the second power. Well, yes, I could have thought of that, but I thought you had to work with a parenthesis first. But anyways, I guess it works because the minus is outside that main parenthesis, is in the second gray parenthesis, so it can work like that. So it's still all to the second power, still the same stuff. Okay, now what? We have a second power right there, so I really don't know, like this is some high geek stuff, so AP stuff. I'm only on the SAT. AP is just on accident, some elements from there. So we got a 2 right there. I mean, I knew about this property, like whatever, like you applied it, whatever. And you could just simplify that, so it's gonna be x to the second power up front. Okay, so now we're gonna have like exactly two terms like the same. LOG3 and 3 minus x the same. Only thing is different is the thing up front, so on the left thing it's x to the second power and the right thing is minus 4, so I think we can just cancel them out or what. We can factor it out. Okay, so it's factored out. Now what? Right there, x to the second power minus 4, a formula can be applied. X minus 2 in parentheses times x plus 2 in parentheses. But why do I care about that? Is that what we should apply right now? So we're going with a system like this. That is with a sign flipped, and that again with a sign flipped. I don't know why. God damn, like, I'm just gonna close this, like, no thanks. I don't want a perfect grade. Like, goodbye, man. What is this? Get out of here. This is some proper geek stuff. Let me see this. This should be like comprehensive V8 preparation. Okay. (2022) what 20? This was in 2025. Like, anyway, okay. I guess they can take the exams that were before, like way before. Okay, so we're gonna solve this right. I mean, this one's easy, like 5th grade in China. 32 write down 2 power 5th. The 5 we move to the power to the right. So it's going to be 15 divided by 5, so that's going to be 2 to the power 3, which is 8. 8 minus 8 is 0. I can do this with my eyes closed. Okay, so that's done. Now this. Bruv. This one is easy, like this. You have this P of X, and you have to understand basically the x minus 2. What is the rest of basically that. So to do this, x minus 2 equals 0. That is going to be x is equal to 2. Swap it in, P of 2. And that's it, man. Like, that should be it. This is just easy. Done. Plus 1 right there. And we have 2 times 8, 16. Plus 4, 20. Minus 10, that's 10. And we got 11. And that's it, man. Solve this. First of all, DVA. What's under the square root must be bigger or equal to 0. So pop that, which will lead us that minus x is bigger or equal to minus 4 and swap the signs, x is smaller or equal to 4. And that on the graph will be from minus infinite till 4 with parentheses that is not circular. And now just pop everything to the second power. We'll get some quadratic stuff. We'll solve that. Use intervals, see what's positive and negative, basically. Now actually here we don't need positive negative, it's an equation, not an equation. So just get values that match dVA and that's it. Okay, so first dVA correct. What? I fucked up, guys. X minus 2 also has to be like that. Why? What is this condition? Based on what? Should I actually understand based on what condition this must be like that? I don't remember it being like this. Anyway, fuck the conditions. You gotta do it like this, you gotta do it like this. Less understanding, more mechanical intuition. So, two like that, and we're done. I suppose now we're gonna place it on a line. 2 and 4. From 4 goes all the way to minus infinite, and from 2 goes all the way to plus infinite, so the interval will be from 2 till 4, like that. Okay, now this next second step, as denoted here, everything to the second power like this. There we have formula, x to second power minus 2 times x minus times minus 2 once again, and plus 4. Okay, so just 2 times x times 2, huh? Not actually times minus 2. Okay, based on the formula is that. And so we have x minus 4x plus 4. That's that. And now just move it to the right, the elements. We're just gonna have x to the second power minus 3x. Essentially, that's it. Equal of 0. And there you have two ways, with delta or with factorized. Okay, so that's simplified. And we have received... Yo, I can't see. Okay. So factorized it is, x is 0 or x minus 3 is 0, which leads us to the second solution being x is 3. And let's see which one is admissible. So it has to be between 2 and 4, inclusive, which is 3. The value that works is 3, so write down solution with a adequate parenthesis, and that's it. So let's get on with it. Next exercise. Another one like typical algebra solve, nothing crazy. 1.5 right there. So 1.5 as a fraction is 15 divided by 10. If I simplify by 5, that is 3 divided by 2, which I don't know if it helps me. Let's see the LOG part. 2 base, square root of 8. Well, the square root of 8 can be written as, the 8 can be written as 2 to the power 3, but who cares about that? 2 at the power of 3, and if you take into account the square root is the power of 1 divided by 2, you can pop it as 2 to the power of 3 times 1 divided by 2, which is the power of 3 divided by 2. So LOG 2 and 2 will simplify, so we'll just have 3 divided by 2 plus 3 divided by 2, which is 3. That should be it. It's so easy. This one you can just say it out loud. You don't need paper. Okay, so you get this. 3 divided by 2, just 1.5, that's all it is. So 1.5 twice, that's 3. Yeah, that's all it is, man. Next up, some imaginary stuff. I mean, it's not actually an imaginary exercise. I'm not talking to myself. I mean, I am talking to myself, but it's actually a real exercise, but of imaginary numbers. So right here, I think we need to understand what the z is. We have this, and well, you can just swap it the z, and then instead of a z, you just pop a plus bi. Out of the second power is going to be minus 1 to solve that, and work with real imaginary numbers, like just split them and work like that with them, and yeah, like what else? That's it, should be it. So you just write down then lastly the z number. Okay, so she chose to do this method. This is another method. Just you take the thing to the right, you just make it like this. So after this, you need to multiply with a conjugate, which is the thing below is 2 plus I, so just multiply with it, but instead of plus you put minus, so it's gonna be 2 minus I. So you're gonna work like that, and you're gonna essentially work like that, and you're gonna get out of second power and work with that. So you see, I know exactly, like, I've done like 10 of these, maybe less, but anyways, I think I remember how it's done. So below you also pop that, not only above, and so you'll have 10 minus 5i right there, and below you will have what, there's a formula, like it's gonna be the first term to the second power minus the second one to the second power. So 4 minus I to the second power, and I to the second power is minus 1, so 4 plus 1 is gonna be 5 below. Okay? Okay, so this one is actually quite easy, like goddamn how easy. It's gonna be 5 below, and then I'm gonna split it. It's gonna be 10 divided by 5 minus 5i divided by 5. So we're gonna have 2 minus I. That's it. Z is 2 minus I. So essentially get this, boom, boom. You can just factor it out if you want. That's the way. So it's 2 minus I, Z is 2 minus I, and that's it. Okay, now we're off to some matrices. So find x for matrix equal of 0. Solve matrix, you just multiply diagonally minus the other diagonal multiplied. You equal that to 0, you're done. Here with powers, you just try to get the same base and you're done, man. Okay, so work with it. 4 power of x right there. Minus that like that. So you got that. I mean, you can see that the common base will be 2. So you can already start working. Before you write down as 2 at the power of 2, so it's going to be 2 at the power of 2x with the x right there that is already present. The h, you write it down, actually don't write down the h right now. It's a 32 right there, so that is 2 power 5, so work like that. Work like that, you get this, you get that. Okay, so if it's with the same base and it's multiplied, what you need to do with the power is just plus them out. So you'll have 2 at the power of x minus 1 plus 2x. Easy as that. Okay, so we got that. And x with plus 2x, 3x minus 1 right there with power. and 32 is 2 to the power 5. So now you're just gonna work with that. You have minus right there. So what you're gonna get is like 3x minus 1 equal with minus 5 if you move that, but actually it has a minus already. Hold up, let me see. Okay, so it has been moved like that. Okay, so it has been moved like that, and now we can work. 32 is 2 to the power 5, so we have the same base, so we'll have 3x minus 1 equal with 5, which leads to 3x equal with 6, so x is going to be 2. And that is the x value that we wanted. Alright, so we got this. Bro, see, this live stream has the easiest possible exercises, which is good, but you know, I'm not gonna have to research this exercises forever if I already know how to do them. I'll move up to some moderate stuff, rehearse that. Okay, so 81, that's just 9 at the power of 2, but you see there are 3 right there. So you want something that is at the power of 3, so you can work with that. So 4 at the power of 3 is actually 81, right? Because it's 4 times 4, or actually no, is it not? 4 at the power of 3. How much is that? First you got 16, then you got 4. Again, okay, so that is 64. That doesn't work. So I don't think there's a number that's at the power of 3 is exactly 81. So we're gonna have to resort to 9 to the power of 2. Or we can also go 3 to the power of 4. That also works. Anyways, if it's 3 to the power of 4 right there, under the square root, to remove a square root, you need to... So basically the square root normal one is 1 divided by 2. This one over 3, it's 1 divided by 3. If it were a 5, it was 1 divided by 5. So in our case, it's 1 divided by 3. And so we're going to have 9 times, and then at the... It's actually not times. We have... Actually, let's go over 3 at the power 4. So we have 3 base, and then the exponent is going to be 4 times 1 divided by 3. So it's going to be 3 at the power of 4 divided by 3. Okay, so below I have a 9 of that power. I can write it down as a 3 at the power of 2. Multiplying the exponents is going to be 2 divided by 6, so that is 1 divided by 3 right there at the power. You can notice something common here, right? 1 divided by 3 below, and if I don't work with 1 divided by 3, just leave it at the power, I still have 1 divided by 3 on top. So if it's like this, I think I can do the minus between the 1 divided by 3, and so I'd be left with essentially just 81 divided by 9, so that's going to be 9. Yeah, that's it, man. We just completely eradicate the powers and the square roots, and we'd be done with it. So it has been written out as 3 of power 4. Let's see the approach here. Okay, so the power, like I said before, and that is the power. Okay, so we have the power again simplified, and it's the same term, so I think it's gonna be just written out as 3 at the power of 4 divided by 3 minus 1 divided by 3. So that's going to be 3 at the power of 3. So actually that's 27. So I fucked up or what? It's not 9? Okay, I think I fucked up. It's actually 3. Okay, so perhaps I didn't work with the powers correctly on this one. But anyways, it's 3. It's actually 3. Okay, so I'm gonna move on from there. Pretend like that didn't happen. Okay, it happened, but anyways. Managers already explained how it was done. Like, right here, you work with that. Z is essentially A plus BI, you can swap that in. And you just work from there. Okay, so that is swapped in. We pop it in like that. Minus 2i. Absolutely no issue whatsoever. Now there's formula right there. Everybody knows that's formula. No. But anyways, it's formula. Here it is written out with red text, so it's easily visible, so we get exactly that. And now 2i. Now we have their I to the second power is minus 1, so 2 minuses we get plus. So it's just going to be 5 minus 2i, which is the complex number. So I think we're done. Easiest stuff. Done. Okay, now this one's a bit harder, but I think I did something exactly like this, so I think I know how to do it, like, boom. Here's like the same stuff. With an exponent, you gotta have the same base, so you can work with exponents, equal the amount and stuff, use the properties. Okay, so here I think the exponent of choice will be 5, because 25 is can be written out as 5 to the power of 2, and 0.04 you have to take a look at it as a fraction. So you have 4 at the divided by 100. Simplify, and you will have 1 divided by 25, which is 5 at the power of minus 2, because minus flips it. And below you have 25, which is 5 to the power of 2. So we have the same base. We just work with exponents. That's it. No need no DVA. No need no tricky formula. That's it. Just a basic, some basic properties, and you're done. So 2 times 2x right there is going to be 4x. Okay, so we have that. 25 right there. It's just going to play out exactly as I said. Remember property from before. If it's times like that with the same base, just plus it out. So you have that. So that's going to be flipped. And you're going to have 1 plus 4x equal with minus 2. And what you get from there, 4x is going to be equal with minus 3. And x is going to be equal with minus 3 divided by 4. Okay, so that is some explanation right there, and that is it. That's the solution. I'm gonna take a quick break and be back. We're gonna be doing it like an hour and a half more, stuff like that.